When you visit my YouTube channel, you will know that I've made and showed many circuits of multivibrators, astable multivibrators especially, and many more types of oscillators. But when you want to know more, and especially going back to the more or less basics of all these circuits, go to worldradiohistory.com, click on the UK link and then Radio Constructor, and you will find many circuits from older magazines of the 1960s, and they are very informative, and that's why I want to show some basic things. Anyway, this is the name of the article: Practical Pulse Techniques for the Amateur. Well, let's look at them. Here is, for instance, a quite interesting circuit. And of course, 1966, they had to be or were made with germanium transistors. Perhaps they were made with silicon transistors. I don't know that exactly, but such a circuit is so elementary that you can use it with germanium transistors and also with silicon transistors. Only idea is very important to tell that when you use it with silicium transistors, this resistor could have a higher value. Now it's 15 kilo ohm, and I'm more or less sure that it works with when you want to use PNP transistors like they are used here. You can use the BC557 two times and say lift up the value of these two resistors here, 15 kilo ohm. And be aware of the simple fact that these multivibrators sometimes don't want to start when you add suddenly a voltage to the circuit, but when the voltage to such a circuit is slowly driven up out of, say, 0 volts up to 12 volts. So, feel completely free to use here the BC557 in case of a PNP, and when you give it, the whole circuit here, a positive voltage, you can use the BC547B. It will also work, and well, I have to say the waveforms are not very ideal, but for a first experiment it's absolutely useful. So let's go to other circuits. This is a monostable trigger. It means that it does not give out by itself spontaneously a waveform related, of course, always to the time-dependent elements in such a circuit, the capacitor and the capacitor, this capacitor, and the resistors. So here you can say add a pulse, and then the circuit will work. And here are, say, in a certain way described how the pulses must look like and how the output is. Well, this is a quite good output and reason for a serious test in this case. So again, PNP transistors are used. You can use the BC557 in this case with a negative voltage. You can also use the BC547 in this case with a positive voltage, of course, and there are no, say, capacitors that need a certain polarity. Anyway, But of course, say when you change the value of this capacitor, the circuit will work in another frequency band. So let's go further. Monostable trigger. What's this? A bistable trigger. Well, I never made it, but anyway, I want to show the schematic. There are two inputs, and they give out, monostable trigger, they give out a quite good pulse. And of course the whole, where it all works is set by, in fact, all the components in the circuit. But this part of the circuit here is a time dependent circuit, and also this part here. So they set for a big part how this circuit will work. Astable trigger. And again here PNP transistors are used. When you want to use NPN transistors, reverse the voltage here. So this gets positive and this gets negative, and use here the BC547 and also here the BC547. So a lot of inspiration in all these old radio magazines. Move the camera somewhat. So let's go further. What's this? The Schmidt trigger. Well, the Schmidt trigger, there are many schematics, circuits on my YouTube channel about the Schmidt trigger. Here it is again made with PNP transistors, and the negative voltage here you can use here a positive voltage, and you can use here NPN transistors. They will have, say, the same effect. Problem with this circuit is that it is in a certain way practical, but also there's no good indication here about the input voltage where this Schmidt trigger switches. So, and perhaps when you read the complete description on worldradiohistory.com, I did not do that, by the way. I only want to look, say, give it a first glance to the circuits that are showed and that I made in the past, so I compare it to, say, the Schmidt trigger circuits that I made in the past and published on YouTube. So that's my reference. Anyway, it's worth to give it a try. Let's look further. And I got a comment in the past that it's not a very good idea to well, I will give time to read this. It's not a very good idea to film circuits via the screen of a computer, but anyway, the so-called emitter follower, well, that's a very famous one transistor amplifier. Here it is again made with the 1966, I think, germanium transistor. It's an emitter follower, but you can make it with a not with a PNP transistor and also with a NPN silicon transistor like the BC547. Use in that case here a positive voltage, and my advice is do not use this 22K voltage divider, but use a potentiometer with of 25 kilo ohm. And to protect the transistor that is in use, you must always protect it against a too high base current. So when you use here a 22K potentiometer, in case of a PNP transistor, so with a negative voltage, you must limit the maximum current that can flow from the negative lead to the base. So the potmeter needs a 1K protective resistor here to the minus. So when you set that transistor to its bias, it protects the transistor from directly burning out. When you say align the potentiometer a little bit too much, for an NPN transistor you need the same 25K potentiometer, and at the upper node a resistor of 1 kilo ohm, and then of course the voltage is positive, and we must protect the NPN transistor against a too high positive base current. So you need also in that case a 1 kilo ohm protective resistor. I hope it is a little bit clear. This is, by the way, a little bit uncommon. Normally in the this is the emitter follower. Well, that's correct, no problem. But when you want to use it as a collector follower, perhaps it's here. No, it's not here. You need here a resistor in the order of 1 kilo ohm, and here a resistor in the order of 100 ohms. And the ratio between the two resistors set the amplification, and to get more AF amplification, you need here a capacitor in the order of 15 nanofarad up to 100 nanofarad or so for the situation where you want to use this in an audio circuit. Anyway, there are many circuits on my YouTube channel where I have explained this much better. Anyway, let's go further. The Darlington emitter, again made with two PNP transistors. Of course, we read 1966, where the NPN transistor was less common. You can make the whole idea again with silicon transistors. Use here a positive voltage, here a negative voltage, and do experiments with the voltage divider here till you get it properly working. And I want to refer again to what I told, say approximately 1 minute ago, about the limiting the maximum base current. Well, that was a somewhat complicated, but anyway, let's go further. I have 2 minutes on my camera, and perhaps it's far too long, but anyway. Bootstrapping means that you give that one transistor circuit a very high input impedance. It's done here again with an PNP transistor. You can use a BC5 or 7, that's an NPN transistor, and give it a positive voltage, etc, etc. I have to stop because I'm on 14 minutes on my camera. So anyway, the whole idea here is that germanium, I think germanium transistors are used, but when you want to copy them to modern times, for say NPN silicon transistors, the supply voltage must be changed, and when you use electrolytics, of course the polarity of electrolytics must be change. So I stop it now, it's on 15 minutes. Thanks for watching. Again, old school. You can, like I thought, convert it to NPN transistor with a positive voltage with the minus on ground, and do some experiments here with these two resistors. When you need, say, a 1 transistor amplifier with a very high input impedance. Thanks for watching again.